Hello, Physics Nation. My name is Nate Larmond, and I'd like to solve a Khan Academy problem in a problem set called Choosing the Best Kinematics Equation. So I think this is in high school physics or AP Physics 1. It says, Honor drops a ball from a height of 10 meters on Mars, where the acceleration due to gravity has a magnitude of 3.7 meters per second, or meters per second squared. We want to know how many seconds the basketball is in the air before it hits the ground. Okay, so as the exercise implies, this is sort of a matching exercise. What do I know? What am I going to figure out? And what mathematical model will help me get there? So what do we know? Okay, so this height is the change in vertical displacement. So it starts at 10 meters and it ends at 0 meters. So final minus initial would be 0 minus 10. That is in our traditional coordinate system. So up is positive, to the right is positive. So that's a displacement. We're dropping it from rest, so you can assume the initial velocity is 0. And this free fall acceleration is, about a third of Earth's free fall acceleration. Every second, the projectile will change its vertical velocity by 3.7 meters per second squared, or 3.7 meters per second every second. Anyway, that's down. So again, that should be negative. So we actually have a negative displacement of 10 meters, a negative acceleration. And we just should go through these four choices. So this is actually two average velocity equations squished together. I'll show you my sample calculation in a little bit. This is the definition of acceleration in y equals mx plus b form. I call this one the fancy kinematics equation without time. This is final velocity, initial velocity, acceleration, displacement, and this is the fancy kinematics equation with time. So let's see. Here we go. Always draw a sketch for me, please. So we're on the surface of Mars. Here's the given information, and we have a negative acceleration of 3.7 meters per second squared. Like I said, a negative displacement of 10 meters. No initial velocity. So how about the definition of acceleration? Change in velocity divided by change in time. Well, it doesn't include the negative 10 meters of displacement, so this one's no good. It does have time, that's what we're looking for, but we don't know the final velocity either, so we're stuck. We don't have the average velocity, so this is one way to say average velocity, the vertical displacement divided by the elapsed time, except we have the vertical displacement, negative 10 meters, not the elapsed time. Here's the other way to say average velocity. It's the average of the velocities, so it's the initial plus the final, all divided by 2. Except we don't know the final velocity, and we don't know the average velocity, so we're kind of stuck right there. But this, see how both of these equations equal the average velocity? Well, Khan Academy sets them equal to each other and solves for the vertical displacement. So that's kind of interesting. Right here is final velocity squared minus initial velocity squared equals 2 times the acceleration multiplied by the vertical displacement. So we could find the final vertical velocity. We have both the displacement and the acceleration and the initial velocity. So just for fun, we could find the impact velocity of this thing. But look at this one. We have the vertical displacement. We have the vertical acceleration. We're looking for the elapsed time, and this term drops out because there is no initial vertical velocity. So just for fun, I threw in the numbers, and you find it to be 2.3 seconds to fall this huge distance. 10 meters is like 3 stories. But because the acceleration is so gradual, it takes a long time, over 2 seconds, 2.3 seconds. Thanks for watching. See you in the next video.